So in this report we're going to discuss our experiment we did on disturbance of the chemical equilibrium. Okay, so for a chemical reaction of this type, we have the equilibrium constant that can be expressed as followed at equilibrium. At a constant temperature, the value of the equilibrium constant will remain as a constant. For a reaction consisting of two reactants, a reaction will take place when the reactants collide with each other. The rate of collision will continuously decrease until equilibrium has occurred, which is characterized by an equal reaction rate in both directions, as we see the picture demonstrating. So Le Chatelier's principle states that upon introducing a stress to a chemical system, the system will shift towards restoring its original state. And when looking at Le Chatelier's principle in general, there are four different ways of stressing a system, chemical systems. These stresses include introduction of a catalyst, which is in the bottom, and change in temperature, concentration, and at last pressure. But when looking at our experiment, we're only going to focus on the stresses involving temperature change and change in concentration. When looking at this ratio, we see that Q will always be equal this, which it will always be equal K. And this is only true when the system is in equilibrium. So if you change the Q, then you change the concentration and it will no longer be equal to K. Then what is K? Then it's explained by the change in temperature. And when you change temperature, the K value changes, and you can look at how the equilibrium will change depending on this. So if the new K value is smaller than the Q value, then the equilibrium will shift towards the left. And if the new K value is bigger than the Q value, then the shift would happen towards the right. When looking at our experiment, we are going to stress a specific reaction in all sorts of ways. One of these ways involves decreasing one of both reactants individually, and doing so requires a particular chemical method which will be described now. And one of the reactants is iron 3, which concentration can be decreased by reducing iron 3 to iron 2 here by ascorbic acid as the reducing agent. This is observed by a change in color. And then the concentration of the other reactants, thiosulfate, can be decreased by precipitation upon introduction of silver ions to the system. This is observed through a milky white precipitate, and the following reaction represents the precipitation, which is seen here. For our experiment, we're going to mix an equilibrium mixture, which consists of these three chemicals, and we're going to test this reaction. So when we mixed it, the observation we made was that it went from clear or colorless to being yellow and then to being red again. And we see that the rate of reaction is very fast. And this is the equilibrium expression for our reaction. So what we see in our chemical equilibrium is that the reactions, they get together to form our product, which is in here. And like when they go from products to reactants again, we have them, the two atoms splitting up and becoming reactants. Then as the middle arrow shows, that when this happens, the reaction is going forward and the other one is going backwards. And this reaction is constant, which the two arrows represent that it's happened. Like there's an equal amount of both reactions and products because they're both reacting back and forth at the same speed. So in the first test tube, we are going to observe what happens when we increase the concentration of the iron 3+. And what we observed is that the liquid turned a very dark red color. The explanation for this is that we increased the reactants, which led to a shift towards the right. And as we see here, and then according to Le Chatelier's principle, we increase the iron 3 plus molecules, which created more reactants, which then caused the equilibrium to shift towards the right to create more products so that it can establish an equilibrium again. In the next test tube, the stress to the system involves a decrease in iron 3 concentration. This is done by reduction of iron 3 to iron 2 with ascorbic acid. And the observation is that the mixture turns clear or colorless. The explanation for this is that decreasing the concentration of reactants leads to a higher value of Q. And since the system always seeks to restore Q to be equal to K, the system will shift towards a lower Q, which corresponds to a shift towards the left. Okay, so in the third test tube, we added or increased the thiosulfate, and we observed that the liquid turns more red. The explanation for this is that we increased the reactants, which lead to more product and therefore shifting towards the right. And we see this by the reaction here, that we had the thiosulfate, which we increased, which by the Le Chatelier's principle again would make the equilibrium turn to the right to restore equilibrium. In test tube number 4, we added silver nitrate to decrease the thiosulfate, and we did this, as mentioned earlier, by decreasing the thiosulfate ions by the silver ions. And the observation we made here was that the liquid turned more clear or colorless, and the precipitation occurred. The explanation for this is that there was a decrease in reactants, which led to a shift towards the left to create more reactants. For test tube 5A and B, we are going to make a change in the K, which is a change in the temperature. Then for the test tube 5A is the test tube where we'll heat it up, and for the test tube 5B is the test tube where we'll be put in an ice bath. And for test tube 7 is just a reference tube at room temperature. So what we observed for 5A is that the liquid turned more clear, and the explanation for this is that the heating results in a shift towards an endothermic reaction, and therefore it will go to the left. And this means that the K will go down. For test tube 5B, we saw the liquid turning more dark, which is because the cooling had created a shift towards an exothermic reactions, which, as said, goes to the right. And this means that K goes up. Okay, and what we see here is our collected results from 1 till 5. And what is especially here and important to notice is the test tube 4, where the white precipitate was formed by the addition of the silver nitrate. Okay, so for our experiment, there can occur a couple of experimental errors relating to the results and having effect on them. And one of them could, for example, be an error when it comes to measuring the exact volumes we needed. And another could be, for example, that the way we perceive how we look at these, or perceive the different color changes is kind of subjective as well, and therefore can have a big effect on the results, as said before. But as we saw, in general, the results lined up with Le Chatelier's principle, as we in the theory section predicted it would. And we also observed that a clear change in K was observed upon changing the temperature. And that's pretty much all I had to say for this experiment and report.